Hi everyone, today let's solve the problem number 209, minimum size subarray sum. So what the question states here, we are given an array of positive integers. You can clearly see here we have been given a positive, this one, array of positive integer nums here and a positive integer target. So you can clearly see here, right? So it consists of the nums array, this one nums, and the target both consists of the positive value. So the nums here 2 3 1 2 4 3, the elements within the nums, right? Nums array basically all, those are all the positive numbers and the target is as well. So we have to return the smallest length of the contiguous subarray whose sum is greater than or equal to target. Again, I'm telling, they have strictly mentioned we have to return the smallest length of contiguous subarray. Contiguous subarray means if we consider this one 2 3 1, we cannot skip from 1 to 2. We have to consider 2, right? Then 4, then 3, right? We need to consider every element one by one, right? So we have to return the smallest length of the contiguous subarray whose sum is greater than or equal to target, right? So if no such array exists, if no such subarray exists, then we have to return 0. If no such subarray exists, then we have to return 0, right? I hope this part is completely clear, right? Easy to understand. Just give me a second here. Just give me a second here. Yeah, here let's come to the first example. We have target 7 and we have the numbers this one 2 3 1 2 4 3. First, here in the explanation you can clearly see here the subarray 4 comma 3 has the minimal length under the problem constraint. Means 4 comma 3 will lead to 4 plus 3 nothing but the target. Here in this case this will be 7. This will lead to the target 7. So 7 is equal to 7 when we compare. So in this case, we have we have to return the number of elements that is present in the array, right? So this will be 4 comma 3 nothing but 2. We have to count the elements, so this will be 2, right? So let's go with the second example and the third example as well, right? Simple to understand. So here we have target 4 and the nums we have is 3, three elements in the array. So here we can consider either this 4 or this 4, which will yield to the target 4 basically, right? When we compare, so here in the array we have only one element and we return the count as output, nothing but 1. So this one, right? I hope this part is clear. Here we have the target 11 and we have these many ones in the nums array. So 1 2 3 4 5 6 7 8, 8 elements are there in the array, right? So here 8, quite obviously when we sum up all the elements, that is worst case basically, uh, when we sum up all the elements in the nums array, it will lead to 8. It will never lead us to 11. Whether it can be 7 6 5, it will lead to 1 2 3 4 5 6 7 and 8, but it will never lead to 11. So in this case, as per the question, right? So if no such a subarray exists, then we have to return 0. That's what they have given in the question, right? So here in this case, it will never lead to 11. So the output that we need to return is 0. That's what they have given for the output. So I hope the question part is completely clear, right? I hope the question part is completely clear. Very easy to understand. Let's do one thing. Let's discuss the approach followed by the complexities and then let's write the code. So let's consider the same first example that they have given in the question, right? So that it will be easier for us to understand this. So this here we have target 7 and nums equals 2 3 1 2 4 3. We'll start with start 0, start equals 0 and sum equals 0. Before that, let me tell you, we will be making use of the two pointers. Means we will be making use of the sliding window basically along with the two pointers, right? So we will be making use of the sliding window along with the two pointers. Here start, initially start will be 0. Means this one will be start the element 2, 0th index, and sum is also 0. Sum acts as a counter basically, sum will be 0 as well. So here in this case, we have, it doesn't act as counter basically, sorry. Sum, we need to update the sum every time of the window, particular window, right? So we will expand the window with the end pointer. So this is nothing but the start equals 0, this is nothing but the starting point, and we will expand the end pointer. So initially start and end will be at the 2 itself. We'll expand. Next, what happens here, uh, first step, it will be 2 comma 3, it will be 5. 5 is not equal to 7 or greater than 7, right? So next endpoint we will move to 1 basically. From 3 to 1, right? So next it will be 2 plus 3 5, 5 plus 1 6, 6 is not less than or equal to 7, I mean not equal to 7 or greater than 7. Next we will check, we'll move the end pointer to this one 2, so this will be 8. 6 plus 2 will be 8, right? So 8 is greater than 7, so this satisfies the condition, and we will be adding 2 3 1 2. We will be considering this window first, 2 3 1 2. This will lead to 8. Basically it is greater than 7, the target 7, right? So since we will follow the same steps, here, and we will find all the window, we'll check for all the windows which is greater than or equal to the target value. In this case it is 7, so in this case it is 7. This is one of the window that I showed. You can just try it out for every window. I insist you to try it out for every window, so that you understand the question clearly, right? So that you understand the solution part clearly, sorry, not the question, solution part clearly. And it will, when you understand the approach, right, it will be very easier to write the code. It will be very easy to write the code, means the exact thing, we have to go with the approach in such a way that whatever we discussed in the approach, or whatever we are thinking, our thought process will be in the approach, the same thing we have to articulate in the form of code when we write the code, right? So here this is one of the window that I showed, so please do try to for all the windows where you get this one, value of the window, the value of the window should be greater than or equal to the target value. So here one more value, so I'll just consider this value directly, 4 comma 3, as they have given in the solution here. This is also 7. We have to consider the least number of elements that is present in the window, and we have to return the count of it. Basically in this case, for this we get 7, 4 comma 3 is 7, and we have two elements that is present in this window. 4 comma 3 is nothing but the 2, so this 2 we return as output, so the output that we got is equivalent to the output that they have shown in the example 1. So our approach works absolutely correct in this case, right? So our approach works absolutely correct in this case. So here you can clearly see they have given the same thing here, right? Let me read this one for you, or let me show this one. Expand the window with the end pointer, add the values to the sum, stop when the sum is greater than or equal to target. That's what we did. Now we will try to shrink the window from left while keeping the sum greater than or equal to target. Means we will update the minimum length every time. We will update the minimum length every time. So we will repeat the this one above till the end of the array. So we'll do it for all the elements. We have to check for all the elements, right? Every time you have to check for every window and update the this one. What do you call? If the tar value of the particular window is equal to or greater than the target's value, then we have to add that one to the this one. uh, then we have to basically count the number of elements that is present, in the window, and we have to update the min length. And finally, out of all the this one minimum length that we got, out of all the values of the minimum this one out of all the values from the windows that we got, which is greater than or equal to 7, we will go with the minimum number of elements that is present in the particular window. In this case we got 4 comma 3, right? 4 comma 3 means two elements, only two elements that will lead to the target 7. So we'll be considering this one, right? So here we have the walkthrough for the first example. Sum equals to 5 6 sum 8, window 2 3 1 2, exactly the same thing I showed, right? 2 3 1 2 they have given here. This is valid because this is 8. Length is length is basically, for this length becomes 4, right? So we have to return the this one, what do we call, minimum, the window that consists of minimum values, right? So here in this case we considered this one, so minimum length found, that is 2. That's what uh, we have discussed earlier. So I hope the approach part is completely clear, very easy to understand, right? I hope the approach part is completely clear, very easy to understand. What shall we do now? Let's do one thing. Let's discuss the complexities and then let's write the code. So what will be the time complexity here? The time complexity would be quite obviously big of n, because we are visiting the each element at most twice, once by the end pointer and once by the start pointer. So the time complexity would be quite obviously big of n. And what would be the space complexity? We are making use of only constant extra space here. For the variables we'll be making use of sum, start, end. So these are the variables we'll be making use of, right? It's just a guess. So when we write the code, you'll get to know this. So we'll be making use of the constant extra space here that will lead to the space complexity big of 1. So the time complexity would be big O of n for the code that we'll be writing, and the space complexity would be big of 1 for the code that we'll be writing. So this will be the time complexity and this will be the space complexity for the code that we'll be writing in the future. I hope this part is completely clear, right? So let me delete this one. Yeah. As we are completely familiar with the approach and the code, let's start writing the, as we are completely familiar with the approach and complexities, let's start writing the code. So first step is, let's get the array length. We'll be making use of the array length everywhere. Let me assign this one to particular variable, some variable, right? So here int n equals, I'll just give nums dot length. So the first part here would be, we have to store the minimum valid window length, right? So I'll just consider min length variable name. Let me assign this one to integer dot max underscore value. So this is fine. So next step here is we have to go with the current window sum, nothing but here int sum equals 0, and we have to go with the start pointer of the sliding window. We need to consider start and the end pointer, right? So end pointer will be making use of it in the iteration because we have to move the end pointer step by step by initially considering the start at the 0th index, right? So let's initialize the, let's initialize the start to 0. Let's initialize the start pointer of the sliding window to 0. So here what shall we do? Let's go with the iteration part here. Let's go with the for loop here. This one will be int end equals 0 and less than n, and let's increment the end. This will be n plus plus. So within the for loop we have to expand the window by adding the nums of n. So this we know, we have discussed this one multiple times during the approach. So this will be same thing we are articulating in the form of code, nums of end. So here one more thing, if while sum is not enough, we have to try to shrink from the left side, right? This we know. For that, sum has to be always greater than or equal to target, right? So this is the condition. So for that purpose, it has to be always true. Let's make use of the while loop here. So here this has to be sum greater than or equal to target. So this is fine. Within the while loop, let's do one thing. Let's update the minimum length. When I say let's update the minimum length, this will be min length equals math dot min of min length. This is fine, comma end minus start plus 1. So we are just updating the minimum length, right? If we found every time when we find that the whatever the value that we found in the window is greater than or equal to the target value, right? So next step is we have to shrink the window from left. For that, so let me give here sum equals sum minus nums of start. This is fine. The final step here is we have to move start forward. So nothing but here in this case, let's increment the start, right? So let me come out of this one entirely. The final step is if no valid subarray is found, then we have to return 0. This is one of the edge case they have clearly mentioned in the question. If no valid subarray is found, then we have to return 0. So I can write in this way, I can articulate in the form of code in this way. If minimum length equals integer, not, so this has to be in the capital letters basically, max underscore value. So the value is 0. If it is present, if it is not present, then 0. If it is present, then we have to return minimum length, right? So this is it for the code. So let me format the code once and let me hit the run button. I hope this works, man. Let's see. This has to have the so line number 17 max p I have given, this is just max. So let me hit the run button again. So here you can clearly see all the test cases are getting passed. The sample test cases are getting passed. Means the code works absolutely correct in this case. Let's do one thing. Yeah, let me hit the submit button. Let's wait. I mean, let's check whether this works for all the test cases. Yeah, now you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So I hope the solution part is completely clear. I hope the solution part is completely clear along with the approach and complexities. For now, this is it. Thanks for watching, guys.